Are we ready to start? Let's wait for 1 minute. Okay, you're ready. Okay then. So, hello everybody. It's a big pleasure for me to be here. Thanks guys from Zina. It's a big pleasure to see all of you guys, both offline and online. My name is Igor, and we're gonna talk today about UI tests and how make them work for you. A few words about me. I'm working on Kareem Driver's Android app, and also I am one of Kaspresso's authors. I am one of the main contributors and maintainers, and also on my previous jobs I was also working on UI tests adoption, so I have a little bit of experience to share with you guys. It would be a pleasure for me. So what exactly are we gonna talk today about is right here. So it would be pretty hardcore technical speech about Android internals and a little bit of cross-platform things at the end. So yeah, first disclaimer, and actually first piece of advice that I already gonna share with you guys is please think precisely, do you really need UI tests? Because UI tests are painful, you know? You can't do this just for fun or because it's fashionable, because they cost a lot. Like, it will cost you a lot to adopt them and even more to maintain. And you will gonna need a group of engineers working on it full time, and they most likely will look like this. So that's why you need to see your goal very clearly. And so most likely the goal is reducing time to market, right? So we need to deliver our releases fast and they should be reliable. And if you have some tricks to achieve that, not using UI tests, please try that first. And if you still are here, let's start. So probably if you start in the way, you will look like this. I already like this slide. Because there are a lot of approaches, a lot of tools, and it's definitely not clear what you should choose, what you should not. And we will start from basics, actually. So I believe everybody of you guys have seen this pyramid. Today we will focus on the top of it and talk about end-to-end and integration tests in Android. So the very easy thing to implement actually is end-to-end tests. So basically you just get your Espresso or your Automator, write your test, and voila, you have end-to-end tests. The main advantage of it is that it is real. So it's to some extent it is just automated manual tests. So it's real user scenarios, but for the same reason they are very flaky and slow. They're slow because well, they're being executed on the device, not on the host JVM. And they're flaky because, well, this mechanism is quite complex and we're accessing the real network here in real server, which might be unstable. So what other options can we have here? We can replace our real server with test server, but it still be maintained. Also, we can not access real network, we can mock it. This one can be tricky, depending on your architecture. And if you have a lot of requests going on, you may face mock maintenance hell. We could automate this. We can use something like proxy server, which will act like man in the middle and work in two modes, recording your real server requests and replaying them. Also, we can go further from end-to-end tests and make UI component tests, like separate tests for a single activity or fragment or view. And also we can mock not only network, but even the Android SDK. Roboelectric allows us to do so. So these tests will be executed on the host JVM. But it comes also from starting from the version 4.0, we're able to write even UI tests using Espresso with Roboelectric. But it comes with some restrictions. So basically, we'll not have UI. There will not be ADB, UI Automator, and most of all, moreover, you will not be able to jump between activities. So it can be just component tests, only for single activity or fragment. And the last thing that can be mentioned here is screenshot tests. So they can be placed here like a spectrum from end-to-end to pure integration tests, because basically you can run through your real scenarios and make screenshots, or you can maybe test your design system and make screenshots only for separate views. And other ways, you just need to check these screenshots with the reference screenshots, compare them pixel by pixel. So yeah, this is the main idea. And we say all these tests here, they are different. They cost differently. They serve for different goals. They need different infrastructure. They are different in their reliability. And it depends only to you, on your product, on your team, which of them to choose. Actually, you can mix some of them. But the main thing that they all are sharing is that they are instrumented tests. And we're going to talk about it more detailed. So first of all, why are instrumented? Well, because they're using instrumentation API. So instrumentation is the entity that lives in your app's process and serves as the communication tool between system and your application. So it's responsible for creating application, for creating your activities using reflection. It manages activities lifecycle, and also it is possible to post key events, motion events to the main thread. And the main idea here that we have instrumentation runner. So this runner is the implementation of instrumentation. Yes, so it changes the behavior of our process, and that in order to run the tests. Let's see how it does so. First of all, what happens when we click that green play button in the studio? Here comes two applications, two APKs being built and installed on the device, and they will communicate with each other during the tests. First one is your tested application. The second one is tests APK. What lives inside it? Actually, your tests that you placed in source at Android test, or Android test some built variant, or even in some dedicated Gradle model for that. Moreover, there is a class of your runner is being packed in that APK, some special activities, and of course manifest, which is being generated for us. If we take a look into this manifest, we will see the node instrumentation, and we see that our runner will be used as instrumentation. And we can see here target package. It is used for binding your tests to your APK that have been under the test. So after all these applications are installed on the device, their manifests are being merged into the global system manifest. And you can just check via this command all the instrumentation runners that are installed on the device. Here we can see that runner from our package is binded to our tested app. Okay, so probably you have noticed this command in the logs of the studio, adb shell am instrument, where it is an activity manager here, am, passing some flags test to be run in our runner. So let's take a look what does this command. It forces activity manager service, the system service, to start a process for our app. This process starts regularly, normally. Our main thread is starting to run. And first thing that it does is handling the binding of our application. So all the process configuration happens here. Here you can see how the context of our tested app is being created. And then we see this method. All the magic happens here. We can see that our tests APK is being loaded here. Then the second context is being created. So we have two contexts for both APKs, but single application class. Then we just get class loader, load us our runner, and instantiate it. It will be placed in the field of activity thread and will be used as instrumentation. Next, our runner is used to create our application. Being the instrumentation, our runner doesn't override this method in which the application is being created, but we personally can do so. If you need to, you can create custom runner and override this method, and that's how you can get control over the application is being under the test. So you can, if you have DI here, maybe Dagger, you can change or even replace your root component, mock some dependencies for tests, and so on. Or even you can just use the dedicated application class for your tests. It might be helpful. And here, just maybe fun fact, you can access your runner from the test. Just that simple, you get instrumentation casted to the runner. So depending on what you're implementing, you can do so. After that, our instrumentation runner receives bundle of arguments. These arguments are actually flags from our AM instrument command. Some work happens here, and then this moment, the instrumentation thread starts. It is the second thread. All previous things took place on the main thread, and here comes the new thread on which all the tests will be executed. So our main thread lives its just regular life, and then all happens on the instrumentation thread. The JUnit is being configured. Here we have test request. It contains all the classes to be run, all the class paths to the tests in the test APK, and binding test to runner. Wait, what? Again, runner? It might be confusing. I already told that naming is the hardest thing in the programming. Yeah, you probably used annotation run with, and here you can see that runner, Android JUnit 4. It is the plain JUnit thing. It is responsible for using reflection for creating our test, finding our rules, finding methods annotated with annotation test, and executing them. So yeah, one single runner is used to run one single test. After that, we have run listeners being set in JUnit. Yeah, so run listener is also a plain JUnit thing. It is being notified by JUnit on when all test run is started or finished, or when each test is started or finished or failed. And the description, it's something like metadata of tests, is being provided to us. Yeah, it contains all the annotations, all the class names, method names, so some meta information that can be used for example, for reporting. Yeah, you actually can create your own run listeners, and you can implement, for example, thing for reporting about your tests run. We will return to this later. Yeah, here is 4 ways how to add your custom run listeners. You can just pass it to the command. You can add it to the test APK manifest. Also, you can use instrumentation runner for that, because here in arguments model we get under the field listener we get the string of all system runners, comma separated, and we can add just our custom runner listener class name to it, or we can use that JUnit for runner. Actually, this way is more flexible, because you can run different tests with different runners, and different run listeners can be set. So if you need this flexibility, you can achieve that. And after that, when JUnit is configured, tests are started. They've been executed sequentially, one by one, inside one thread. They launch the needed activities, communicate with it, pass some k-events, motion events to the main thread. Then the activity is closed, the next test starts, again the new activity is launched, and so on. And after all the tests are finished, Activity Manager service just kills our process. So how exactly our tests communicate with app? Some magic is going there. Probably you used activity scenario rule or activity test rule that is deprecated now. They both are implementations of the JUnit interface test rule, which is also being notified when the test starts and finishes. And yeah, here you can see we're just starting activity using some tool called activity scenario. It is pretty interesting thing. It uses an abstraction called activity invoker that is able to open your activities in a new process. It is done for the safety sake. It just uses our tested APK context to start the activity. It uses bootstrap activity to start the target activity. And when your test finishes, bootstrap activity just sends a broadcast to our host process and finishes itself. Also, activity scenario can help us with some other things. We can just move our activity to some state created, resumed, and so on, or even just recreated and verify how our activity restores the state. But personally, I have never used this. But I used this one on activity. It is interesting because, as you remember, we're now on the instrumentation thread, and if we need to do something with application UI, you can do so, right? So you need to be on the main thread. And this one posts your action to the main thread. Why it can be useful? If you need to create some component tests. So what approach is used here? We can use some blank empty activity and set some views, remote views or fragments just from the test. So you will be able to test your components in separation. Here we can see we're accessing our scenario. Here we are on the main thread, so it is safe to create, to inflate the view and just add to the view hierarchy. And yeah, you can normally access it from the test. And actually, this trick with the fragment is recently implemented by Google. And now we have fragment scenario. Actually, it works in two ways. You can launch your fragment without any UI. And the second way is, as I said, it launches the fragment in the blank activity, so we can use it. So, how our buttons are being clicked? What that magic is going there? For example, we have Espresso library. It is white box testing tool provided by Google. White box, it means that this thing knows a lot about our app's internals. For example, it has access to its error class. It lives in our process, in our instrumentation thread, actually, and it posts its actions and assertions to the main thread. And the main thing that these actions are being executed only when main thread is ready for that. So when it waits for users' input, when there is no pending messages, where it is idling. Okay, so how it happens? Espresso uses a low-level API called UI controller. Actually, it is possible to post our clicks, swipes, touches into the main thread. It's our motion events, k-events. And it is possible to loop our main thread until it's idle. So it is implemented using some empty signal messages that notify us when they are called, we're in idle. So personally, as a user, we use more high-level API called view interaction. We post our view assertion. The new callable has been created, posted on the main thread executor. And once it is called, we loop the main thread and then perform our assertion. So this approach makes Espresso tests way more stable than, for example, UI Automator. This thing works in a different way. It is a very powerful thing. Actually, it is a tool for black box testing. It means that you don't need to access any app's internals. You don't need to know anything about the test. And that's why you can access even system applications or just different applications and click buttons in it just using UI Automator. So how is it possible? UI Automator uses Accessibility API. We have Accessibility Manager service, which lives in its own process, and it just uses binary PC to gather all the information about any screen displayed on your device. It stores its own virtual tree of components, and UI Automator has an access to its tree. It can check all the nodes and even pass some actions to it. Okay, so if you want to test some service, we have servers test rule for that. It works both with started services, bound services. For content provider, we have provider test rule. Yeah, just read the documentation. I just notify that you have the ability to do so. And what if we need to do something special with the system or with the device? To do something that needs ADB, right? Because what's the trick here? ADB is debug bridge from our host machine to the device, and we're now in the device. But actually, we can do so. We can call ADB shell. We can use UI Automator for this, or just plain Java process builder. But here's the trick. You can't use ADB emo here. So it is not possible to make a call or set geolocation or something like that. This command should be called from the outside of our device. Here's the first problem. And there are a lot of more. Espresso works badly with asynchronous UI. So if you're waiting for some backend response to show some view, Espresso won't wait out of the box. So it just will fail your tests. Google says that you can use idle resources for that. I would say no. It is not very comfortable. You need to implement the separate class for each asynchronous operation, and you need to store this test code inside your product code, which is weird. And also it contains some problems which may lead to race conditions. So we need some other tool. And also it will not save us from flakiness. Espresso is also flaky. If you click one button 100 times, one of its 100, it will just fail somehow for some reason. Also, there are a lot of problems with Automator. It works badly with custom views because if they are not implemented properly, they might be invisible for accessibility. Also, it works badly with asynchronous things because it's for each action, for each your click, it waits up to 10 seconds for the 500 milliseconds window when there will be no messages in the main thread. So it makes your tests very slow, and in some cases, for example, some animations or video playback, it may just freeze forever or fail your tests. And also, tests will fail. They will fail not only because they are badly, just because they do the thing which they should do. If you have some problems in your application, tests should fail. And we need really rich test reports to understand what is the problem. Standard reports are not so rich. Also, there's a problem with Espresso's dump view hierarchy log. It's just painful to find the cause of the problem. And remember, I said about run listeners. We can use that. We can use this thing to structurize metadata of the tests, store it on disk, and use somehow for HTML report generation. But you even don't do so, don't need to do so because you have Allure. It is the open source tool for creating good-looking reports. But here's the one thing, you need to provide some data to it, right? So metadata about our tests is not enough. We need logs, we need screenshots, and videos also would be great. So yeah, it would be better to have some history, what button on what screen, on what step was clicked, and what was the cause of the problem. Also, Espresso and Automator has not very convenient API. Also, with a release of Compose, we have the third tool. It looks like Espresso, but it is not Espresso. Yeah, we need to solve this. Actually, for Espresso and Compose, we have Kakao. It is also open source library. It provides some syntax sugar for you. It forces you to use the pattern called page object. So basically, it is the screen, a representation of the screen that you are using, that you are seeing. It should be stateless. Yeah, so we just write our screen like this, and we can access it from the test. Actually, it looks much more pretty. And still, your Automator is not wrapped. We need to agree about the patterns and code styles and all the things that we use, because otherwise, your team will look like this. I will explain. We have a proverb in English called invent your own wheel, but in Russian it is invent your own bicycle. So I give you 100%, all your team will be riding all kinds of bicycles. And here's the solution. Just a little bit of advertising. It is a cool tool called Caspresso. It combines a lot of things that will help you, will just save you time. Yeah, it provides Kakao DSL. I won't read this. I will just show the simple tests using Caspresso. It will Yeah, it is. Also, one thing that should be mentioned here is we provide ADB server. So it is the jar file that is being set on your host machine, and you can ask it from the test to execute some ADB command for you, even ADB ammo. This is very powerful thing. And also we have steps DSL, which does a lot under the hood. It uses the main feature, I guess, interceptors for creating logs, screenshots, videos, retries, auto scroll, all kinds of things that will help you to make your tests more reliable. And also it works well with Allure. It can be customized. You can write roboelectric tests using Espresso, and so on. And at the end of the presentation, I will show you some video just for fun, how it works. So, seems like all our problems are gone. You're wrong. We need to run our tests. And it's also the problem, because here you can see our tests are being executed one by one, sequentially. And this means if one test crashes our process, the following tests won't be executed. Also, they can share some state. If some tests, for example, authorizes the app, the second cannot expect the application to be in the authorized state. Yeah, the tests can share some state in the memory or the static, and this all lead to flakiness. So what can we do here? We can use ADB shell command, but here's the trick, it kills our process. We can do this from the test, but we need to clear data. How can we achieve so? The naive solution is just to write a bash script, right, and to run our tests just one by one in its own processes and clear the state after each other. What can be the problem? Actually, there are no, it will work. And moreover, this logic is implemented by Google in its solution called Orchestrator. So it is another APK that you've been installed on your device, and it does pretty the same logic. It uses the fourth application as a ADB proxy to call the ADB commands, but it does this thing. If you set the flag clear package data, it will also clear all the data between your tests. But here's another trick, because this operation is quite expensive. It forces our app to be started in cold regime, cold starts, and for some products it might be very long. It might take 10 seconds, 20 seconds. So maybe the good compromise is to batch your tests in some group and let them share the state within the same process. So not large, single test and single process, but launch some group of them. And also the standard tool doesn't give us optimal sharding, because it may lead to some devices idling. It's suboptimal. We also need to retry some failed tests, not all the whole test run, just single tests. We need some statistics to monitor flaky tests. Long story short, we have a tool, open source tool, that will do all these things for us. It is the test runner called Marathon. It can be used like Gradle plugin, or it has command line client. So it can be flexibly configured using YAML file. It has a lot of retry strategies, batching strategies, all things that you can see here. And it works both for iOS and Android. And it can work with real devices and emulators. But the main thing that you will need your in-house infra. So this might be not very fast to implement, but it is a very powerful thing. A lot of companies use it. So my advice to you. But if you need some quick solution, you can use Flunk. It is a runner provided by Google. It also is a cool thing, but it is paid. It works with Firebase Taste Lab. So yeah, it may work in your case if you're just starting and you want to see some fast results, or there are not so much tests to be run. It can work for you. The last thing, we should decide which should we use to run tests. These both runners work with real devices and emulators. What should we choose? So real devices, well, they're real. They can highlight some vendor problems. They don't consume your CI resources, but it's also painful because they're not reliable. There can be some network issues. There can be system dialogues will ruin your tests. And just its disk, memory, GPU is not that reusable as your host machines, right? So they will go out of service very fast. And you will need to maintain a farm of these devices. Probably you will need storage with climate control, because I personally seen how batteries inflated because of too much using. And the second option is emulators. Actually, they're faster. Let me explain. They're faster because it's easy to keep them fresh. For example, if you'll take a fresh real device, an emulator, the test will probably be executed faster on the real device. But in real life, it isn't possible to have fresh device for each test, right? And so emulators win this race in real life. Also, they can be configurable because most likely you don't need sensors, gyroscope, audio input. You don't need this for tests, right? Also, you can reduce the resolution to some small values. It might have some speed up for you. And also, emulators can be launched in headless mode. It means that you will have no UI, right? It sounds like weird, but it is possible to have UI tests without UI because your views, well, they will have only out passes, on measure passes, but there will be no on draw, and you still can verify the UI. Also, it consumes resources, but the great thing about emulators is that you can use Docker for it, and it will just simplify your life a lot. It's easy to start them, to kill them, to connect to some runners, and so on. So yeah, there are a lot of images you can use. And yeah, finally, we came to conclusion. Like a conclusion, I would show you some video. Here we have some runner that builds our test APK. Testing APK installs it on the device. Tests are written with Kaspresso. We have some strange flaky screen here. It has a list with views that just randomly change their text. Espresso test will fail here already. Kaspresso survives. Then we making some text input here and checking if our activity restores the state after the rotation change. ADB command is used here. We use ADB server. Then it is still inside the test. We go to the browser. Inside the test, we open the Kaspresso GitHub page, and then we can even return to our application. And we will make a call and receive an SMS via the test. It is also implemented using ADB server. Here it is. And so our test passes, as we can see here, right? 1, 2, 3. Yeah. Then our script pulls all the files that are stored on the device because we recorded logs, screenshots, videos, and we call alert to generate a report for us. Here we can see the alert report, how it looks. Our test passes. We have all the steps, all is readable. We can see screenshots binned to each step. We have a log for our test run. We can see what button on which screen is clicked. And also we can see the video report here. So, yeah, thank you. It is a good note to stop, actually. How can I stop? Yeah, we can discuss it later. Thank you for your attention. Yeah, so maybe you have just a few words, okay. Please remember that your tests will always be flaky. It is the sad thing, but the great thing that you can reduce this flaky rate to some accepted value that they will work for you. You can't avoid manual tests because there always will be unpredictable things that can be catched only by human eye. And actually, there are some scenarios that are too expensive to be automated. Also, it is the must. Your tests should be a part of your CI. So they should be run very often, like continuously. It will not work at all if they were launched only locally. So nightly builds, nightly runs, PR checks, release, of course. Yeah, and think about this as a long-term investment. In the long-term distance, it can reduce your release cycle. And that's all, finally.
Thank you for the awesome talk. It was really, really insightful. You mentioned there are a lot of reasons why tests may be flaky, and I want to ask about one of them, like the async operations that are happening in background. And you mentioned that there is what's it called, idling resources, right? And do not use them. There are other approaches like waiting until something appears on the screen. Do you have some other suggestions on what works best in your experience, like for handling this flakiness caused by asynchronous stuff?
Sure. Yeah. I will share one thing that is implemented actually in Caspresso, and we use this pattern from guys from Avito. They teach us so. Actually, we can. In simple words, we can use just thread sleep, right? So not just thread sleep, but in Caspresso there are some more interesting implementation. But the idea, let's say, it's thread sleep because all the tests are being launched in the instrumentation thread, right? And we need the instrumentation thread to stop while the main thread will just run. And we can implement something like cycle. We can try to click the button, catch the error, wait for some time, and try another time. Yeah. So.
Essentially just waiting until something is available and try until it is, right? It's as simple as that, without any idling resources, any actually marking stuff that it's ready, just waiting. And this is most effective way, right?
I'm not sure it's most effective, but it works actually. You can set 1 second for waiting and try another time. So it doesn't cost actually a lot. You even don't need to synchronize your threads. You just try now, try again. Yeah, it works.
Thank you.
So what is the threshold for this? How many tries should be for test to fail?
Yeah, actually it's up to you. So we have some default settings in Caspresso, but you can customize it. By default, it checks twice a second and waits, for example, for 3 seconds for each click. But you can, actually, in the test code, you can force for some action to be retried for more times or less times. So it's up to you. There are some default implementation, you can change it. Yeah, by the way, about Caspresso, if you start in a test adoption, it will save you a lot of time. But if you already have a lot of Espresso tests and you're not planning to migrate, you can go and check the repo, and maybe you'll find something interesting, some approaches. For example, you can use ADB server. It can be used in separation. So, yeah.
Hi, Igor. Thank you for a pitch. Probably you have a big experience in UI test and helping the teams to start UI testing in their products. Imagine if I'm, for example, an engineering manager and I have an Instagram application. I go to you and say, Igor, I don't have UI test at all. How much time, how much resource I need to investigate, and when I will receive something good for me with this result? What do you think about it?
Actually, it depends, of course, on your application, because I worked in AliExpress and we had a lot of legacy, Chinese legacy, no documentation at all. And there were problems on each step. So it took, I don't know, half of a year to start. And for example, in Kareem, the code is better maintained. So actually, we don't need Caspresso. There are some wrappers over Espresso, and it works. We have thousands of tests. They're running and they're helping us. So first of all, we need to look into the application. So how much manual testers do you have? How much your release cycle is how much time it takes. Maybe it's work for you if you have, I don't know, 3 hours to run all the regress. I will say you don't need UI tests. And actually, in Yandex, it is a big company. It's like Russian Google, and we had very interesting thing. There was accessors testing. So basically, we have our test plan, and these tests are being applied to some users that are connected to some program, and they will act like testers, but they outsource. And each test is applied to 3 different persons, so we can cross-validate it, and it works. So we use them like automators, like devices. It will. You will need to pay them, but you will need to pay in all the cases to Google for Flunk, to your engineers in your in-house infra, or so on. So, to ask one word, it depends. 2 words.
Okay, thank you.
In a large code base, it could become a problem to run tests because your test use grows and grows and grows, and at some moment it will take like 1 hour to run all the instrumentation tests. They could fail, and then you need to wait another hour. So what are the ways to optimize test running performance and test running time?
Actually, you probably don't need to run all the tests for each pull request. For example, I will share some idea. We can run all the tests only at night builds, and we can validate which tests are flaky and which are trusted. We can, let's say, take 300 tests, which are 10 out of 10 green, and use them on the daily PRs as the blocker. So it will reduce the time of your tests run. It will increase the stability. And yes, so the whole test run should be used on the nightly builds, or maybe for release candidates tests. There is some approach. So yeah, it's just multi-complex system, and you design it for your needs, depending on your goals, depending on your how much resources do you have. Yes, probably you can add more machines and parallelize your tests better, use Dockers, Kubernetes, and just optimize all this stuff. Or you can, just reduce tests amount.
There's some insight from a mono repo in Yandex and in Sberbank and Sber devices. We had a mono repo with a lot of apps and different tests, and it's good to set this up, like run the tests only for the code that has been changed. It's on pull request. Yeah.
So I want to ask about concurrency of tests.
Mhm.
Like, do you run multiple test cases within each startup and teardown? Because as you see, you clear the storage, shared preferences, stuff like that. So do you run multiple test cases concurrently, or do you run a separate Docker image as you showed us Docker for each test case and let it run separately?
You can run test cases concurrently inside one device, so we can run them concurrently on different devices, right? Inside each process, they are run sequentially. It's GUnit is designed so. And you can. It depends on how much resources again do you have. If you run each test in its own instrumentation instance and clear all the data after each test, this will increase the waiting between tests. It might be, it will take some time. You can group them by 3, by 5, or depending on you, to run in the single instrumentation thread. So we open the app, 3 tests, and we clear it. So it's just empirically can be figured out which batch, you can have here.
And the Marathon API, it's like I saw it being used in CI/CD scenarios. It's like process hatchery or something like this.
It is the jar file that is hosted on your CI machine, and it runs the tests. So it needs the devices to be connected to it, just via the IDB. It doesn't know about is it real device or what. So you can provide, like Docker images, or using just scripts, using AVD manager. And Marathon runs this orchestration by itself. So, for example, if you have some failed test, it will, if it's possible, it will try to retry it on the next device to exclude the device problem. So pretty like it does all for you.
Thank you.
Hello. Sorry, I'm not a mobile developer, so the question might be silly. So whenever we are building tests for mobile, so let's say if your sorry, if your application is mostly a real-time events-based application, for example, Messenger or Slack. So how do you plan your test cases for mobile? Because everything actually comes from server through WebSocket. So you might have text messages coming up, images or PDF. So it's always like based on some other actions, then you basically reflect on your application.
So the question is how to emulate the real server communication?
Yeah, so
yes,
all of the like a new messages comes in or video comes in or files comes in. So everything is basically you are waiting for some events to happen, only then like you can show something on this application UI. So how does like you approach this thing to be like make the application testable?
For chat application, I would say there's no way for end-to-end tests. Basically, it is crazy to synchronize two applications to communicate with each other. So I probably would say you need to mock your server, use this dedicated server, or use some mocks inside your apps and to maintain this. So it shouldn't be. It is impossible to make it real, right? So
then then we will also have to need one backend developer who actually maintains a mock server only for the cases.
You can, for example, you can use Sniffer. You run this test when you're developing tests locally. You send requests, catch it by Charles, for example, or Wiremock, or Wireshark, or whatever. You take this JSON, put it into the in the repo, and you need a tool to return it to you. Or you can use, for example, there was, it will take too much to return to the start. There are tools called Wiremock, Catbird, OcReplay. It is proxy servers that will act like a man in the middle. So you just set it on the CI, and they will proxy all your calls to your real server. They will record automatically all the requests and replay them to you. So if there are some hell with mock maintenance, you can automate it. But all of this stuff, it will be a tough technical task. You need to investigate.
Okay, thank you.
How do you actually decide when you need UI tests and when they can be replaced by integration tests of different, like let's say with mocked API layer? When do you actually go for this expensive option that is flaky and that's unreliable?
I think the easiest response is when your regression testing of your release candidate takes too much and you're not satisfied. So when your project code base grows, I guess the manual testers that are needed to test it grows exponentially. So sometimes you don't have place enough to sit all of them. So you need to automate some things. So for example, in Kaspersky, we had the release cycle. We released like 1 in 3 months, and we had feature freezes, and that's why we needed to migrate to 1 in 2 weeks releases or 1 week releases. And then you need UI tests. It is, you need to investigate. You will take half of a year or maybe a year to fully build it.
Do you think some of them can be replaced with integration tests? And if yes, what is the probable criteria?
I will just reference you to the standard pyramid of testing. So first of all, you need unit tests, some integration tests, maybe for using Roboelectric, it will be faster, and for your repositories, for your view models, and all this stuff. I'm not sure actually, does view model need to be tested in unit tests? It's also discussable. So yeah, UI tests is the last part. It is last thing that you should think about. If you, first of all, you need, it is used, it gives a lot of results when it is inside of a process. So first of all, you need to make a process starting from unit tests, for example. You need to force the developers to write tests and not to disable them because they're hurrying and this release is very important. So first of all, the process should be built and then you can think about your tests.
Thank you.
Hope you're not sleeping yet.
No, it was really interesting.
Thank you.
Thank you guys for coming, for listening, for asking questions. Yeah. Thank you all. Thank you all. Thank you, speakers, Vlad, Igor. Thank you for speaking today. Yeah, and that was Minimobile Meetup number 2. It's not regular one, not regular meetup, but yeah, let's see. Stay tuned. Subscribe to our meetup.com page. Yeah, and
let's thank Anthony for gathering all us here.
Thank you. Yeah, stay tuned and follow us. Yeah, thank you for coming.